Okay, I think we have officially, I think we've officially slowed down. So we got a pretty good audience here today. Hello, everyone. Welcome to our monthly automation workshops. First of all, I'd like to just go ahead and say welcome back. If you, oh, I'm sorry, I'm not sharing my screen. But for those of you that attended our Texas Automation User Group, and I'd just like to thank you guys for your patience as we rebooted this at in a larger scale to not just include my fellow Texans friends. So thanks again, everybody. I really appreciate you coming out here. We're going to cover some really interesting things today. It's going to be focusing specifically on APIs and where they are within the networking space, how to interact with them. We're going to be learning a little bit of the ins and outs of APIs and how to interact with them. And we'll also talk about some of the more common tools that are used within the automation space to help your day-to-day life in operating with APIs. And as always, on these workshops, it's really small on slides. I try to not overwhelm it. I like to do everything as live demos, mostly because that gives us opportunity to break things. So hopefully it's a little bit of exciting for you guys. Again, thanks again for coming. This new iteration of this session, what we're going to be doing is this is going to be the last Thursday of every month. We're going to be having this 2-hour call. We're going to be, again, just today, we're going to be focusing on APIs and introductions. I don't have any guest presenters. I know in the past we brought in Palo Alto, we brought in some Cisco reps as well. But today, this is just going to be me, just going to be Juniper. Although we're not going to be talking about anything Juniper specific, as always, the theme here is to be open and only talk about products that support across the vendor spectrum, because we recognize that unfortunately, not everybody runs Juniper everywhere. And although I would really like it if that was the case, I fully appreciate the fact that there are other decisions that are made for other purposes and reasons. So, all right, still got friends coming in, and that's great. But let's go ahead and get started with today. Let's first talk about what is an API. And what I like to do when I talk about APIs or explain them, I like to first recommend that you drop the P just for a second within the API and just focus on the two words that are on the outside. So application and interface. And the reason why I say that is, to me, that is the most appropriate description of what an API really is. It is a logical interface that we use to communicate with a remote piece of software. Now, that piece of software could be Facebook.com, it could be Twitter, it could be the LG refrigerator that's got a live Twitter feed on there. I know someone here's got that refrigerator. It can be any of those services, but it can also be, an API can also be found within the networking space. So on our actual routers or switches or firewalls or access points, et cetera. So the application interface, this is our method of talking to that piece of software in a programmatic fashion, right? And there's the P. If you didn't guess it, if you didn't read the description on the screen, the P within this equation is the programmatic, and that's the real kicker here. We need to be able to interact with remote pieces of software with some kind of script, some kind of, whether it's Python, maybe it's a Linux curl command, but we need a way to programmatically interact with that because we want our automation to just kind of happen behind the scenes. We don't want to actually be coding and then issuing everything within the Python interpreter. So the programmatic way of interfacing with applications, I know I just kind of took that for a spin there, but that's the purpose of the API. Now, APIs are nothing new, by the way. They've been around way longer than I have, probably more than everyone else on this call. So APIs are nothing new, but why you might be hearing a lot more about APIs today is when we talk about, when you hear APIs mentioned, what they're typically talking about is this rather recent innovation within the web API space, right? I don't want to call it Web 2.0, but it's basically where most of the web services that we consume today, whether again, it's a end user web application like Facebook, or if you're interfacing with Amazon AWS web services, it's typically driven through an HTTP based API. And we'll talk a little bit about that. Actually, we'll talk a little bit about that right now. So let's see, the common APIs that we have within the networking space, we typically have two. Now, the first one I want to focus on is NetConf. Now, NetConf is great for a lot of reasons. One of them is that it is, well, one, it's an RFC standard, so that's already a great thing for us within the networking world, but it is an API that was built explicitly for interacting with network devices. And think of it as its main goal is to really take all of the operation lifecycle that you would do from a manual configuration aspect, or grabbing informations, or building routing adjacencies, or getting information about the status of those routing adjacencies. It's taking all those network-like things that we do on a day-to-day basis, and it boils it down into a series of what they call remote procedure calls, or RPCs. So the idea is that anything that you can do from the command line, whether it's I'm looking for Ldp neighbors, or I'm building a layer 3 VPN, it doesn't matter. If you have the API available for you, then NetConf is going to have, if the NetConf API is on the remote device, then NetConf is going to have the RPC to be able to perform that task and function. Now, the stickler about NetConf that you should know is that the data format that it uses is XML. And XML has been around for a very, very long time. And in fact, the Juniper operating system is completely built within the XML data format. So everything that you see, even if you log in like through a command line and you start building your configuration, you do set commands, you do commit operations, you look at your BGP routing adjacencies, et cetera. What you're actually doing is you're actually interfacing with the XML API through NetConf on our devices. The other thing that really makes NetConf really shine, though, is that it's built off of SSH. So the same exact transport that we're using to connect to our devices, right? That's got a concept of user authentication, AAA, all that good stuff. But also, it encrypts the actual transport. The session is already encrypted. So NetConf just rides on top of SSH. They are directly bound to the hip, and they're using XML as the data format to send and receive data between client and server. In this case, client would be like your Python script or your JavaScript app, and the server in this case would be like your remote network device, your firewall, your switch, your router, what have you. Now, the other common API that's out there today is the REST API. Now, this is, again, I talked about earlier why you might be hearing a little bit more about APIs these days. It's really kind of the blossoming and the taking over of REST and what it's been able to perform within typical software development. You see a lot of applications now moving to web services. Everything's being deconstructed into separate microservices, and you're hearing a lot of these types of terminologies that's happening within the software world. Well, it also applies in the networking world. What REST provides for us is it's using the HTTP protocol, just like we use, again, to probably log in, catch our daily news, find out what's happening in the world, because it's always something going on. So that same web browser, that same HTTP transport, again, that also has authentication mechanisms, has TLS to provide encryption services. REST APIs are going to be leveraging the HTTP most of the time to be able to interact with the remote server, the remote application. Now, the thing about REST is it's not bound to XML like NetConf is. In fact, you will probably more often than not use JSON within your REST API calls, but you can also use clear text. You can use CSV. You can do all kinds of things with anything you can do with HTTP. You can and therefore do within your REST APIs as well. It's just got to be built for that type of functionality on the back end. But that's it. That's the two major APIs that we see in the networking space. Again, NetConf, it's bound to XML, and it uses SSH for its transport to interact with the networking devices. For us as network engineers, that's perfect for almost everything, because the caveat that you have when working with REST and HTTP is that you're going to have to turn on a web server on that remote networking device. And that may or may not be an issue depending on your security policy. But personally, being on the wrong end of years of auditing tools just completely blasting me for having a HTTP server on a router, even on firewalls where it's extremely common. It's difficult to pass some of those security audits with web servers and the networking vendors. It's never really an easy thing to just upload the web service if there was a security vulnerability. So there are some caveats with working with REST, but overall, a lot of the work that's being done today is heavily focused on REST. Although we in the networking space, we are still a little bit spoiled because of that NetConf dedicated API that we have. So whether it's NetConf or whether it's REST or whether it's SOAP or some other, maybe it's not even a traditional API, it doesn't matter. But you typically have in APIs, you have what we affectionately call CRUD. I love it. It's these four basic methods of what you can do with an API. And so what CRUD stands for is create, read, update, delete. And you can think of those as verbs because that's exactly what they are. That tells you what you can do with that API. I can create an object. I can read from the API, or I can delete objects, or I can update an existing object. Now, CRUD is quite universal across the board within its concepts of what it's actually providing, but we call it different things in different APIs. And different APIs also have different functionality as well, in addition to CRUD. So I just wanted to provide this table here that kind of maps out some of the words that you might hear whenever somebody says, hey, you need to do an update to that REST API. You might need to know, is that a put operation or is that a patch operation or is it something else? So although I don't want to muddy the waters too much, just know that you might be hearing terms used interchangeably. Kind of an interesting thing to note, if you look at that last column there, it says NetConf, and the NetConf looks a lot different than the others. Again, remember NetConf is it's XML based, so it's got these little carrots that embrace what we would call a tag. So it embraces the operation that we're performing on the remote API. So I think I'm actually going to be shifting to talk mostly about. I'll be using the REST methods when I talk about any of these operations, just because I typically work a little bit more with REST than anything not. And it's honestly, it's a lot easier to say post than edit-config. So if you see these words, just know that they might mean something else in a different API. So what it is to retrieve data with an API, I just want to provide a high-level illustration of these four CRUD operations, and then we're going to jump into the actual lab so that we can see these things live. So retrieving data with GET, what would this actually look like? This would look like you, the user, would be issuing a command just like you would from PuTTY or from Secure CRT. And the idea is that you would be asking for a piece of information. You're not making a change on the remote device. You're not deleting some configuration on the remote device. All you care about is retrieving that configuration or those BGP neighbors. So in this case, the user sends an API request. It's a GET operation, and the user is asking for the configuration of interface gigabit 001. Now the remote device, in this case my router, is going to return that payload back to the user. In this case, it looks like it's structured clear text as far as a Junos configuration goes, but you can actually signal to the remote server, hey, send me this back in XML or send me this back in as JSON. Again, REST is pretty flexible as far as what kind of data formats that it can work with. Now, what if you actually wanted to create something on a remote device? Let's say you wanted to create an interface configuration that didn't already exist on the remote device. Well, for that, we're going to be doing what's called a post operation. And the idea in this case, the user is going to be creating a loopback 0 interface with an IP address associated to it. Now, what's interesting is that now in this case, it's the user that's actually sending a payload to the remote device. Again, we're being instructive that we want to create something on the remote device. And then even though we're actually sending a payload, we still get a message back from the remote server, right? In this case, when I'm creating something, I'm going to get an HTTP code back of a 201 if I'm operating with the REST construct. So those HTTP codes that you've probably seen across your life, if you've been on the internet for the last 20 years or so, like HTTP 400, 404, HTTP server error 500, all of those error codes are applicable here within the REST API world because, again, it's the same HTTP transport protocol that we've been using. Now, if there is a configuration or an object, as we would say, on a remote device, and we just want to change an element, like in the case that I had created an IP address on loopback 0.
Answer your call as quickly as we can, but we are.
Thank you. So in this case, all I want to do is update the IP address on the remote device. I'm not creating something new. This is what we would call a put operation, meaning that I'm updating something on the remote server. And in this case, what we see here is that the user is actually sending what looks to be the same exact payload, but it's got a different IP address at the end of it. And this is not a post because we're not creating an object. We're actually updating something that already exists. So that operation would be called a put. Now, again, the HTTP server, or in this case, our network device, is still going to send us back a status code to say whether or not it was successful or whether or not you had authentication issues or whether there's some other kind of issue that prevented your successful API call. The last thing I'll just talk about is you can also use the REST API or NetConf API to actually delete operations or delete configurations from a remote device. In this case, my user is sending an HTTP delete, and they're saying, I want to delete loopback 0's description. And the description was delete this description. And even in the delete operation, we still get a status code that comes back to us. And that reality of receiving status codes is a really big part about when it comes to building your automation. When you start building your scripts, you want to have some kind of assurance that your script is operating successfully and that the return that you get back is as you expect. Because in the network automation world, you're not going to want to babysit your scripts. You're not going to want to log in and make sure your script is running every day, or if the container failed or something along those lines. You want to have some kind of mechanism to say, hey, this looks like it actually completed successfully. And if it failed, look for these type of server errors or these types of HTTP errors, and then send that information back to me. So the status code is incredibly powerful tool. When you start developing your own automation scripts, you definitely want to have this construct in mind. Now, let's talk a little bit about some of the more common tools that we see today as far as what users are using to interface with these two APIs. The first one is Postman. Postman is an extremely popular HTTP REST API client. It simplifies your interaction with REST APIs. And it also, one of my favorite features is that it'll also export the API call that you've built inside of Postman, it'll export it into any programming language that you're interested in. So if you're learning Python and you've successfully done some kind of Postman API query and you want to know how to do it in Python, Postman will actually export the code for you so that you can incorporate that within your script. Anything that generates code for you, especially in your starter phase, I'm all for it. Go for it. Absolutely. It's also completely free. And one thing I'll just note about Postman, and this is kind of applicable to the network automation space as a whole, is that Postman wasn't built for networks. It wasn't built for managing routers. It wasn't built for configuring switches. But it's really common in the networking space that we're commandeering a lot of tools that are used out there in other sectors of IT. So Postman is extremely common for things like building clouds, validating web applications, validating APIs. And the reason why I mention that is that although Postman is completely free and cross-platform, they do offer a premium package that is more tailored to the other features that don't apply to us in the networking space. So if you want to build like a mock API server, or if you want to have tests run on demand through Postman, that's great for web development, but it doesn't really apply in the networking space. You should be completely fine with the free product without any kind of concern. Another really great thing about Postman is that it allows you to synchronize all of your what they would call workspaces and collections, basically all your API calls that you've built over the years, and you can sync them across either your Gmail account, or you can work with other teammates and you guys can build your APIs together with it. So Postman, fantastic tool, highly recommend it. It only works with REST APIs though. Don't go try to use this for NetConf, because you're going to have a really frustrating day if you try to get that working. The other one that I want to talk about today about interacting with the NetConf API is PyEasy. PyEasy is an open source tool that we support here at Juniper. It is it's almost unfair to even just boil it down to say this, but it simplifies working with NetConf. It does a lot more than that, but the high level value for us as network engineers that are learning network automation is that this is going to simplify all of that XML RPC calls, building a NetConf connection to a device, maintaining that connection, sending data, receiving data. PyEasy is something that within just a few lines of code, you can actually build within Python and interact with that NetConf API. One of the great things about it is that it's kind of the foundation for a lot of the, PyEasy is the foundation for a lot of the automation stuff that you see out there. So the Juniper modules for Ansible are completely built on PyEasy. JSnappy network unit testing tools also built on PyEasy. Nornir also built on PyEasy, Napalm, et cetera, et cetera. A lot of really great projects have kind of blossomed out of PyEasy. But for today, we're just going to focus on the actual project itself. Pause, break, 26 minutes in. Before I get into the demos, I just want to open up the floor. Anyone, feel free, feel empowered to unmute yourself. If any of that didn't make sense, or if any of it wasn't clear, if you'd like some kind of clarification on any of those points on either REST or NetConf, now's a good time to kind of raise your hand and just put yourself out there and ask your question. If I don't get any questions within the next couple of seconds, though, we'll go ahead and transition to the live demonstrations. It was a really long-winded way of saying I needed a water break. Okay. Well, it sounds like everything is crystal clear. You guys understand exactly what the differences are between NetConf and REST, and you understand that there's different tools that are used to interact with them. Let's go ahead and jump into the live demonstrations to see how well this goes today. I'm going to go ahead and let's start with Postman. So what I wanted to do is I want to first enable the REST API on my Juniper devices. so that I can start consuming Postman to interact with that device and give me the structured output of my API calls. So the very first thing, let's go ahead and jump into my web browser here. And I've got a device. I just wanted to, let's see, what's running right now. I got an MPLS network. Let's look at this really quick. Okay, so this is EvenG. If it just looks unfamiliar and you're not accustomed to what this is my network virtualization lab that I'm running inside of my house. Let's see if the REST API call or the REST service is enabled on my PE router Lone Star PE1. Show configuration system services. We'll just do display set. So it looks like I've enabled SSH on this box. I've also enabled gRPCs for streaming telemetry, and I've enabled NetConf, but I do not have the REST API currently enabled. So let's go ahead and turn that on my networking device. That's quite easy to do. Set system services, REST, HTTP, port, we'll do 8080. And we'll also enable the Explorer. And this is a really great feature. I'm kind of excited that you guys get to see this, but we'll take a peek at that just in a second. Let me figure out what my IP address is on my loopback on my management. Okay, set system services, REST address 192.168.105.25. Okay, and just a really quick show compare. So 3 lines of configuration to enable the REST API on the Juniper MX router. Not too bad in order to get the job done. Let's go ahead and commit that for us. And what I should now be able to do is log in to Lone Star PE1 port 8080. So great. So what we see, let me turn off my dark mode so that things might pop just a little bit better for you. So this is the actual router that we just configured the REST API service on. And what you can see is that when I enabled the option for to enable the REST API Explorer, what we get is an actual web service that we can formulate our RPC calls to our networking devices. So although I'm using the REST protocol to interface with the device, it's still expecting remote procedure calls and akin to the NetConf world to be able to perform its operations on our devices. So this is really great. I could type in here, get software information, and I can say automation Juniper 123. Everyone now knows my password. And what we can see, all right, so what we get within the API Explorer is a really quick understanding as to what the data is from the remote device. So here is the response body. This is what the router sent back to us over HTTP. What's also great about this is that the REST API Explorer also gives you a quick snippet of how to do this from the command line. So if you're on a Linux or a Mac, or if you're running WSL in Windows, there's nothing to stop you from taking that command and pasting it here. And we'll just go ahead and hit the enter button. And now I get the same data back inside of my console. So really, really cool. Again, we're interfacing with the device over the REST API. And in case you're curious as to how to find the appropriate RPC, there's a shortcut on all the Juniper devices out there. A lot of you probably already know about this, but for those that are not aware, should you ever be interested in finding out like what's the appropriate RPC call, let's say you want to find your Ldp neighbors, but you want to do it within an automation context, you know that you need to have an understanding as to what the RPC call is. What does the human command translate to the NetConf command on the back end? To do that, you would just type in the same command as you would always, show Ldp neighbors. You can see it gives us the appropriate text output, but instead you would pipe it and say display XML RPC. And here is your cheat code right here, right? They actually produces the RPC call that you would need to be able to perform this either through the REST API or through the NetConf. So I'll just paste that here and I'll resubmit it. And you can see here the data that we get back is presented here within the GUI. Now, the REST API Explorer is honestly, it's more of a learning tool, a debugging tool. The practicality of using this in production, at least the API Explorer part, this web interface that we're looking at, not so much, because if you're already interfacing with a device with automation, then what's the benefit of doing it through a GUI tool? But I do want to just showcase here one of the most powerful things about using APIs. And if you've ever automated a device that doesn't have an API, this part will make all the value sense to you, is that if you use an API to interface with a device, you get the data coming back to you in structured text. What I mean by that is going back to the conversation we had around data formats. There's XML data formats, there's JSON data formats, there's YAML, there's all these different types of data formats. The most important part though, is that you do not have to write custom parsers to interpret the data that comes back. And with other devices that don't have an API, you'll have to do what's called screen scraping, where you issue a Python script literally from the same console that you would do the actual configuration of the device. And you would have to write regular expressions to parse out that data, to tell your Python script, this key right here, this is an interface, and this right here, that's a description, and this is a router. You don't want to be in that world. It's a terrible, terrible environment to be in. So to have the data coming back to you structured, either in XML or JSON, is going to be an absolute blessing for you on your automation journey. Okay, so we know that we've turned on the HTTP Explorer. How can we use Postman to actually interface with this? So in the background here, I've got Postman, and let me also change, apologies, let me also change the dark mode on here. They recently changed their theme and I no longer prefer the dark one. Let's see, that might be a little bit easier to read. It might have blinded your eyes. If so, I'm sorry. But here is my Postman client. Again, completely free to download, completely free to use. And in here, Postman is going to guide us on how to build our API calls. So there's a concept in Postman of workspaces. You can use these however you want. You don't even have to use workspaces. For me, I create a workspace for each of my things that I interact with. I'll have a playbook like this or a workspace like this one where I'm interacting with Junos devices, or I might have ones where I'm interfacing with my IPAM netbox, or maybe some that I'm building some kind of script with HealthBot or something else. I'll try to assemble all of those into a single workspace. It just makes it easier for me to find at a later time. Inside this workspace, I have what's called collections. And again, just another logical grouping. In this case, I got a collection called Lldp. And here is where I actually build out my REST API call. So we know that we want to do, let's just walk through the first one. We're going to get the Ldp neighbors from a remote router, from a remote firewall, from a remote device. And I just, since I only want to receive the information, I'm not trying to make any changes. We know, because we're all experts now in this, that operation in the REST world is called a get operation. I'm going to get some data back. Now, I'm going to put in the actual URL. Now, this URL was actually the REST API Explorer also provided this URL. Let me just go ahead and copy this and paste it here. But it's going to be just HTTP, the name of your networking device. If you're using DNS, if you just got static IPs or something, you would use that right here. And then, of course, the port number to indicate, what port the service is running on. RPC is the next thing in your API URL, or what we call the URI. That's to indicate that I'm going to be doing a RPC on this device, a remote procedural call. and then we actually pass in that remote procedural call. In this case, I'm saying, get me the LLDP neighbor information. Now, there's a lot of other form fields and sections on here to consider. Now, again, a lot of these will not apply to us in the networking space, but let's just kind of talk through a couple of them. The first one I want to highlight here is authorization. For me to authorize with a username and password, it looks like right here, I'm just going to type in my username is automation, and my password on my device is Juniper123. And that's how I'm going to authenticate. Now, as you can imagine, I'm interfacing with this server over HTTP. There's no TLS encryption. This would be in clear text. Whether or not you feel okay with that in your environment is up to you and your security team. I just hate dealing with TLS certifications on networking devices. It's enough to drive me crazy. But this is how I'm going to actually be performing, I guess we'd call it AAA operations, right? How to authenticate to the device. How do I get my authorization permissions? What can I do? What can I not? That's going to be declarative here within my username and password. Now, the headers section is another one that's really interesting. Headers allows us to send signals to the remote API of what we're expecting or what the API should expect from us. So in this case, I want to accept the data format of application XML. So I can see from a drop-down list that I've got a lot that I can receive from the REST API. But I'm basically telling the remote API, hey, I want you to give me this data back in the structured data format of XML. If you wanted to change that to JSON, you would pick JSON, and we'll show you kind of the before and after. Now, there's no body here, right? There's no body to my request because I'm just asking for information. What information I'm asking for is right here in my RPC. I'm saying, get me the LLDP neighbor information. So I don't need to pass anything on my body. We will be showcasing a different story here just in a little bit, but I'll go ahead and press the send button. And what I'm going to get back is, first of all, there's that HTTP status code of 200. Really, really important. But what's great about Postman is that if you forget what the status code means, you can hover over this, the actual description, and it'll tell you, hey, looks like this was good to go, or hey, you had a problem with your authentication or something along those lines. You also see how long it took for that RPC to process, and you also get the size of the response back. Now, what's also really great about this is that if you're building some kind of automation script and you know that this is the data format you're going to be working with, and you want to just kind of have like a snapshot in time of this specific request, you can click Save Response right here and say Save as an example. And then this payload will always be here for you to, whenever you need to revisit it, to find out, hey, how do I structure either my Python code or my Ruby code or my JSON? What's the data format? Here's a great example of doing, here's a way of saving that output as an example for future use cases. So there it is, really, really simple. You saw us execute through the REST API. I told the API I wanted the data back in XML, and that's what it did for us. But let's also talk next about what it would look like to change it between XML and JSON and how to do that within Postman. So the same things are happening here as far as authentication headers, username and password is being passed into here. This time, it looks like I'm basically doing a show version. That's what this RPC call is of get software information. It's just like doing a show version on your device. And I'm telling the API, give it back to me in the format of XML. Now, if I send that, what we'll see is you'll get the software version. You also see some other information, some parameters about the device. In this case, I'm actually issuing this against an SRX firewall. So you can see the product model, you can see the version of code. You can tell that I live life on the edge by running the bleeding edge code in my house. You can also get some additional information on that package. But again, this is structured in XML. What if you wanted to get the data back in JSON? How do you do that? Well, if you've been following along, you probably already know because I already mentioned it. But let's actually look at that same exact RPC call of get information. And this time in the headers, I'm going to flag that I want the data to come back to me in the JSON format. We'll go ahead and hit send here. And what that's going to do is it's going to reach out to this layer 7 firewall. It's going to get all the software information. And what's interesting is that it's going to take just a second longer. I'll talk about why, but the data comes back to me structured inside of JSON. Now, in this case, the JSON kind of looks a little goofy, right? There's a lot of single objects nested inside of there, but that's just because there's a conversion between XML and JSON that takes place. So the reason why JSON calls will take longer on a Juniper device, maybe a second longer, maybe a little bit less. The reason why, again, is that Junos was built with XML from the ground up. So when you issue your RPC calls and you ask for the data coming back as XML, the device is just going to send it back to you in structured XML. If you ask it to send it back to you in JSON, well, then you're asking the device to convert that XML into JSON. And that small little amount of resources that's required to flip XML to JSON, that takes an extra second or so. So that's why your JSON requests back from the API are going to take a little bit longer. But personally, my personal opinion, since nobody asked for it, is I prefer to work with JSON over XML because it's extremely easy to incorporate within Python in comparison to XML. And Python is my preferred language of choice. But that second of conversion, I'm okay with. In all honesty, most of these scripts happen in the background. I'm never worried about them. I don't have to compute them myself. So I'm okay with the extra second. It doesn't have to stop with really basic examples either, right? In this case, I want to get my BGP L3 VPN routing table from that same firewall. So something that's a little bit more complex. Here you can see in the RPC, I'm asking get route information. Give me all of your routing table. But what's also interesting is that you see here in the URL after the RPC, you can see that I'm asking for the table named BGP L3 VPN. So this is a mechanism for me to say, hey, I want the routing table, but I only want this specific routing table. Do not give me anything else. And the way that you can construct this inside of Postman, you can either enter it into the URL just like this, like kind of a query, or you can pass it into the parameter section. It was a tab that was right next to the authorization. You can ask for the parameters that you want to set and what parameter you're actually looking for. And I know my friend Brian has a question I'm going to get to you just in 1 second, Brian, but I want to show you how you find out what parameter to actually pass within here, because without it, you'll be playing a guessing game that will get old really quickly. So this router, I think, is actually running RSVP session. This is also running MPLS, so I can do this as well. I can do the BGP L3 VPN table on here as well. So if I was to do this from the command line, I would ask for show route table BGP L3 VPN. And here I can see my layer 3 VPN table. It's not very large, but here it is. This is not my global routing table. This is not any other VRFs. This is just this specific routing table. So how do I get that remote procedure call to get this specific table? Well, I hit the up arrow and I say display XML RPC. And I get the RPC, but what's great is that Junos will also say, hey, if you are looking for just this table, like you said here, pass in the parameter of table and ask for the value of BGP L3 VPN.0. So if there was any other routing table that I wanted information on, show route table, what is it, Skyrim.inet.0. Where's my video game nerds? Rise up. Display XML RPC. Here you can see now my table, I'm still passing the same parameter, but I'm only asking for this specific routing table. And if we update our RPC call right here, in Postman, now when I issue this request, what I'm going to get back is the, oh, sorry, that's the wrong device. That's kind of funny. Lone Star PE1. There we go. I was sending that request to my firewall that wasn't going to go anywhere. Now I can see I get the Skyrim table. I see how many routes are within that table. I see the route targets. I see all the great information that you would see typically if you're issuing this just from the command line. You can get it right here within your payload. So I'm going to pause there. Brian, you had a question. You want to go ahead and unmute and ask it?
Sure. Yeah. Sorry if there's a little background noise. I'm outside. You were mentioning the difference between as XML and returning as JSON and a little bit of time differences. My question is not really about that, but it's about sometimes if you request, or actually all the time when you request in JSON format, the switches seem to respond with wrapping some objects in a list, even if they're not things that you normally would have multiple of. Mm-hmm. I don't know if you've noticed that or can comment on that. Because that throws off if we request as XML and then write our program to go through it and later request as JSON, we have to adjust everything because it won't work again.
Perfect. Thank you for asking that one. So what's happening behind the scenes with the competing data formats, right? We've had XML for decades. JSON's, you know, it's not the newcomer on the block, but in comparison, it's definitely newer. The thing that you've got to understand is that in the XML world, there is no concept of a list. Just doesn't exist. There's nothing like a list in XML. And so when you want to have an element tree in XML, and you need to have it represented inside into JSON, what the device is actually doing is it's trying to account for the fact that objects inside of the XML tree may be structured in a format that would be more suitable as a list inside of JSON or inside of Python. Again, it's an interesting challenge because you would think looking at XML data format, oh, that's a list, right? That, well, no, that concept just simply doesn't exist. So what the device has to do, or if you were doing this yourself inside of Python, either the Python library or what the device is trying to do is account for the fact that things are structured in XML as a list or like a list, but it has to account for that and flip it. So the data structure, like again, going back to the example, let's look at that example payload right here. This, you can see just to the point that you made, you're getting a object back as a list, but there's only one. In some cases, there's only one object, like host name. There's never going to be more than one host name on a device. And I'm not talking about clustered or MC lag. Let's not go down that discussion. But I mean, you would think, hey, a single device is going to have a single host name. Why is it coming back to me structured in a list format as far as JSON goes? And that's because of the unfortunate conversion that's necessary between the two data formats. Does that help explain it just a little bit, Brian?
Yeah, I've struggled a bit because most of the cases where I see it, it annoys me because it doesn't make sense to have multiple like host names, for instance, you know? Yeah, I appreciate the explanation. Yeah.
Yeah, no problem. It's common. It's a common annoyance when working in XML and trying to get it to port to something like JSON. You're going to see that, you know, on all API endpoints. So Corbin, you got a question as well. You want to go ahead and sound off?
Yeah, I don't know if I'm jumping ahead, so apologies if I am, but can you go ahead and show us what it would have looked like if you had issued a bad request, basically? Show us the response code and any XML that comes back, like what you started to do with sending the request for the Skyrim table to the wrong router.
Yeah, that's a good one. So really good idea. Yeah, let's show you some failed things. First thing I'll do is I'll just go ahead and I'll strip off the authentication. What you're going to get back is a different status code here. Now you're going to get a 401 unauthorized saying, who are you? I don't know who you are, and I'm not going to allow you to interact with me. So you've probably seen these all over the web as well. If we issued this to a device, and they said this is another firewall that is not running the REST API Explorer, you're going to get a connection refused. This isn't necessarily a status code. This is just a standard. That port is not open on the device, so it's not going to be listening to it. Now, getting back to the one that you mentioned where I had asked for, let's go back to my routing table, and I had issued the request for the Skyrim table on a firewall appliance that didn't have it. Let's just say Dallas Firewall 0. Let's go ahead and execute that. You can see that the request takes a little bit. Well, let me hold on, backtrack. There is a difference as far as resource reservation goes, and I don't mean RSVP, sorry. A next-gen firewall has got a lot more things going on than a router or a switch typically does. So if the layer 7 firewall takes a little bit longer to get back to you, it's okay. But as you can see here, we still got an HTTP 200. So that's kind of an interesting point. And one, I'm really glad that you brought it up, because what this tells us is that our request was valid, meaning the way that we structured it, the way that we authenticated, the RPC that we asked for, it was valid, but the problem was somewhere else, right? In this case, the payload is kind enough to tell us, hey, no routing table matches that specification. So the return payload came back as XML and said, thank you, but these droids are not the ones that you're looking for. So a really good point. I'm really glad she brought that one up, because the status code looks legit, but there's nothing inside of that routing table. Now let's actually send a malformed RPC. Let's do, oh, we're going to do a configuration. Let's do a I'll just play with this one. So let's say the RPC to actually get my configuration from a device is get configuration. Right? But let's say I forgot, I was on vacation for a week and I came back and I still got a Mai Tai hangover. And I think that the RPC is actually get-config. If I issue that here, again, really interesting, we're still getting a status code back of 200, meaning that we've structured our request correctly, but the actual RPC that we call is invalid. In this case, they're saying get config is not a valid RPC. So that's one of the caveats that you got to know when working with REST. You've got these status codes to tell you the success or your failure, but sometimes that's not the full story. Sometimes there's other things going on. So you need to be able to handle that within your code, either make some kind of exception or say, look for this within the message and then take this type of action. So thanks again for asking a really good one. If anyone else has any questions, feel free. The way that I saw those two, they just raised their virtual hand inside the Zoom. I am keeping my eye on that, so feel free to reach out. Let's actually show a configuration change, what it would be like for us to make some kind of config change, because there's a gotcha that you need to know. So going back, in this case, I have a Postman request here that says set system host name. And now my request is no longer a GET request, it's a POST. And if you look in Postman, it'll be a little friendly to you. It'll tell you GET ones are colored in green, POST are yellow. I think delete is red. There's another one that's blue, I think. So they do try to color code it to make it a little bit easier to consume at a high level. But here is a request that's very similar to those that we were doing before. In that there's a URL that we have an authorization aspect to it. There is a difference that I am doing a different HTTP method. In this case, I'm doing a POST. My RPC or my URL is also just a little bit different, and that in this case, I'm just calling the endpoint at RPC. So I'm not running like RPC/get software information or get Ldp information. Nope, this is it. This is the API endpoint for me to talk to, is this URL. Now, what's going to be different is that we are going to be sending information to the API. We're going to say, I want to set my system host name. And because of that, what we should do is we should be good developers and good network engineers, is that we need to signal to the remote API, hey, you're about to get some XML, just so you know, right? And so that's what this header does right here. It's called, we flag content-type, and then we say application XML. So whereas before, we were telling the API, hey, I want you to send me back the response or the payload inside of the XML format. This time, we're actually signaling to the API, hey, we're about to send you some XML, get ready. And so that's what we're doing with this right here, content type, application XML. And because we're sending some information, we need to have a body. So what Postman does is they give you this option to select all different types. I typically spend most of my time right here in raw, meaning I'm about to paste some raw text into this box, and I want you to send that to us. And it's pretty smart it can kind of infer what data format you're using, but just to be on the safe side, I like to flag it as XML just in case it got messed up. And here you can see the actual XML that I'm passing here. It's load configuration, and I'm saying edit the config by saying configuration. And then I'm going and I'm walking down that XML tree of my configuration, just like we had seen here. Oh, that was as JSON, but I'm walking down configuration, system, host name. So that's what you see right here, configuration, system, host name. And now I'm passing it a new host name. In this case, I'm going to call this oops firewall 0. Now, let's go ahead and send that, because there's going to be an interesting gotcha with this that you just need to be aware of. Again, this is a next-gen firewall. It's doing a lot of more important things than what I'm asking it for. But what we get back is we get a status code of 200. It says the load configuration results was a load success. All right, so we feel pretty confident that we know what we're doing. We've changed the host name on that device. Let me log into that device to just make sure. So SSH automation at Dallas firewall 0. Yes, I accept that key. Now, what's kind of interesting is that the device itself, it still thinks it's firewall 0. So what happened, right? We sent an API call to say, I want your name to be oops firewall 0. Well, if you've operated on a Juniper device, this part might not sound too unfamiliar to you. You can make changes, but you have to actually commit them. So when I log into the configure mode, it tells me the configuration has been changed, but not committed. So you need to understand that the operations that you would still, you would traditionally do from the command line, commit, rollback, show compare, those types of things, they're still applicable when interacting with the API. You're not going to get away from that. And honestly, I don't think you would want to either. So if I just did a show compare right here, I can see that the candidate configuration had its firewall name changed from Dallas firewall 0 to oops firewall 0. So how do you actually send the commit operation through the API? Well, there is another remote procedural call. It's also a post, and you can see this is the entire RPC call is commit configuration. If I send that, actually, oh, wrong host name, Dallas firewall 0. Go ahead and send that. Oh, still got the host name wrong. There we go. So what this is going to do is it's going to go ahead and perform all the hundreds of different tests or checks that are made whenever you do a commit operation on a layer 7 firewall. It's going to make sure all the firewall policies are right, IPsec, VPN tunnels, all that stuff is valid, and then it'll actually commit the configuration. Now this takes a little bit longer on the firewalls, just like we expect it to. That's effectively it from a REST API perspective. There's a lot of different great things that we can do. Like 100%, whatever you can do from the command line, you can do from the REST API that we're exposing here. Now, again, my personal preference is to not run REST APIs. That's just my preference. You can do whatever aligns with your security policies. Here we can see that the commit time took about a minute. We even got the database version information that came back. We see that the commit was a success. And if I jump back over onto my firewall, I can see now that the host name has been changed to oops firewall 0. So that's it for REST and for Python, or sorry, for Postman. Actually, I lied to you. Let's do one last thing. Let's go ahead and just export this RPC call to a, oops, I took the authentication off of this one. Let's go ahead and export this code into Python so that we can run it from a script on demand. Now, the way that you do that here in Postman is if you hover your mouse over to the far right, you'll see this code option listed here. Now, from here, you can select on the drop down what programming language you would like this to be exported in. You want it in Golang, you want it in JavaScript, are you a hipster and you want it in Node.js? What do you want this code to be in? And Postman will actually provide it for you. So here is the code to issue our RPC call. If I copy that, and let's just go ahead and roll the dice. I'm going to create a new script here, and let's go ahead and say this as test.py. And I'm going to change into this directory and make sure I have test.py. Oops, move test.py to test.py. Now, if I change, let me load my virtual environment just in case here. Easy bin activate and Python test.py. This is the using the REST API, but it's using it in Python. And as you can see here, we get the same data that came back. So Postman is a fantastic tool to help you get started, help you work with APIs, and also help manage your APIs. And once you become a little bit more familiar with the network automation landscape, you're going to find yourself interfacing with pieces of software in ways that you never would have thought before, right? Your SolarWinds, you would have traditionally accessed it through the GUI. You might find yourself now doing REST API calls to SolarWinds. Same with your IPAM, your DNS services, et cetera, et cetera. So REST is a fantastic protocol, but there are some caveats within the networking space. Let's transition now to talk about, yeah, there's no questions. So let's go ahead and transition into the NetConf world. And we're going to be talking a little bit about PyEasy. Now PyEasy is a Python package. So we're going to be doing some Python here if you didn't put those two things together. So PyEasy has an unfortunate naming nomenclature that can sometimes be a little bit confusing for those getting started. The package name itself is PyEasy. The way that you install PyEasy is to install Junos EZNC. I apologize, it happened before I was here. Traditionally, you would have just installed pip install PyEasy and been off to the races, but this is some of the legacy stuff that we're working through. So pip install Junos EZNC. If you can't put that together, that's Junos as the Junos operating system, EZ, meaning that it's easy, and NC stands for NetConf. So if you're ever in a bar room and you're playing one of those trivia games and they ask you what it stands for, now you know that Junos EZNC stands for, so anyhow, let's go ahead and showcase this. You can see already within the Python script, just, first of all, if you've never seen Python before, I hope that you're not overwhelmed by it. The Python is relatively easy to understand. I say that although it took me a couple of years to teach myself, just a little thick in the head. But at the very top of our script, we're importing packages to use inside of our Python code. So I'm saying on these first 3 lines, I want to import the oh gosh darn it. I want to import jnpr.junos import device on line 1. That's basically saying I want to import the Juniper PyEasy package, and I want to import the function called device. And if you're curious, and I imagine you would be, device allows you to manage connections to devices, right? So it will build an SSH tunnel, or it'll build a NetConf session over SSH to a remote device, and it'll maintain the lifecycle of that connection, as well as handle or pass commands from you inside of your Python code to the remote device. That's what this device function is that we import. Now I'm importing also a couple other things here, a couple other packages just to make things look pretty. One of them is something to make my text look colorful and pretty. That's called Pretty Print. It's an extremely common package. Actually, I'm not going to be using it. Let's go ahead and remove it. And the other one is LXML. This is just a way for Python to interface with XML. And as you remember, NetConf rides over SSH, but it's expecting an XML data format. In one direction or the other, it's expecting to either send XML or receive XML. And that is exclusive on NetConf. You cannot use JSON in the NetConf world, unfortunately. Although there's strengths and weaknesses to both. Just in case you're curious, XML is actually a full-blown programming language. It's got a lot of different tools and functionality to it. It's extremely powerful. It's why it's been around for decades. And JSON is a little bit more lightweight. It doesn't have all the features and functionality, but it's still, it's arguably a lot easier to work with. So you'll see kind of both being used in network automation, but in the NetConf world, you are limited to XML. So on lines 6 through 10 here, this is where I'm actually going to build a NetConf connection to my device using the PyEasy package. And so there are a few parameters that are asked of me, just like it was in Postman. They asked you, what's the host name of your device? Or in Postman, it was what was the URL? What's your username? What's your password? So those typical parameters that we still need to authenticate and build connections to devices, PyEasy is also expecting those. And that's what you're seeing on line 6, where we pass in those parameters to the PyEasy package so it knows how to build a connection. Now lines 7 is a try statement. I don't want you to focus too much about this. Just know that I'm using this to account for any errors that might come up in my code. Don't worry too much about the try and accept if that's an alien concept to you. I just would prefer if you just completely ignored it for right now. But line 8 is where we actually send our RPC to the remote device. So as you can see, we created this instance where we connected to a remote device, and then we called that remote instance, we called it an object called dev. Now you could call this ice cream sandwich, you could call this caramel, pineapple upside down cake. It doesn't matter what you call it, but sometimes it's just helpful if you're a little bit more descriptive to yourself. Your future self will thank you. So I'm building that object, and now I'm saying on that object, on that connection, I want to issue a remote procedural call. And this is the remote procedural call that I'm going to issue: get software information. And I'm also passing a parameter inside of that RPC call to say, hey, by the way, send this back to me in the format of XML. And as you can imagine, you can also change that on the fly as you need to, if you'd rather it to be JSON, or if you'd rather it to be clear text, just like what we did in Postman. This is just another way of showcasing how to do it over SSH. Now, before I issue this, I want to point out something that's, if you're unfamiliar with Python, is going to be kind of confusing. Let's just go ahead and SSH to any of my devices. I don't care. Let's just pick on this one. That looks good. Juniper 1, 2, 3. So this RPC is the translation of the command show version display XML RPC. we can see, yes, get software information is the RPC call that we want to call. But you'll notice in the RPC call, these are dashes in between the words, get dash software dash information. And the actual RPC that we're issuing is get underscore software underscore information. This is extremely confusing for those of you starting out. I understand it. But the reason that this is that Python tries its very best to infer what types of operations that you're passing in, or what types of data formats you're passing into it. And that inference gets confused when you say get dash software dash information. What Python thinks that you're doing is it's thinking that you're subtracting an object called get from an object called software from an object called information. So Python gets a little bit confused because it's trying to look at this line like, I'm seeing that you're wanting to subtract some objects here. So what we have to do is we have to just flip the dash into an underscore. I recognize that that's kind of confusing, and I apologize. It's just the nature of the technology. That's where we're at. The last thing that we're going to do is I'm just going to print this out to the screen. I'm just going to kind of brush over and hand wave over this line right now to say, this is how we print to screen, because I just want you to see it before we actually talk through it just a little bit. So I'm in the directory of 1-0. I'm going to say to issue my PyEasy application or my PyEasy script, I'm going to call on Python and then the name of my script, which should be app.py. Now what's going to happen in the background, that NetConf session is built, all the RPC is called, the data is structured in XML, it's sent back to me, and here we can see it's actually printed out to the screen in beautiful XML syntax. So I guess beauty is in the eye of the beholder. Some people hate XML, but I think it's nice. Now, this line is a little bit confusing, and I apologize. I am kind of brushing over it. The thing that I'll say, again, with XML, you have to understand how to work with XML inside of Python. There's a concept inside of XML called the element tree, which is the entire element tree, just like you see here. This is an element tree. You need to tell Python, hey, I want you to turn that element tree into a string. And I want it to, and here's the name of that object. You can see here, we created the object of show version and saved it equal to this RPC call. There's also some other things that I'm adding, some extra parameters to tell Python how to interpret the data, but I don't want to overwhelm the point. The idea again is that we build a NetConf session with line 6. We pass it some parameters. We actually issue the RPC calls here on line 8. We store that output into a new object that I'm creating called show version. And then on line 12, I'm printing that out to the screen. So before I go ahead and move on, I want to pause to see if anyone's got any questions. This might be your first time seeing Python. This might be your 1000th time, and it still doesn't make sense. I'm going to suggest that take the opportunity to go ahead and ask a question if anything's burning on top of your head. Okay, thanks for the water break. All right, so this right here within itself, not a whole lot of tremendous value, right? I mean, it's great. We're able to get the data that comes back to us, and it's in a structured data format, so I don't have to write regular expression parsers, and I can narrow down exactly what object I want. If I just wanted the host name, I could tell it, hey, look into the XML, navigate the tree all the way down to the host name and return back this value. And when you start building some automation scripts to have the ability to just zero in on any device, any config, any object on that box and say, give me that value right there, without having to write your parsers or anything along those lines, is extremely powerful. This is why I always recommend, if you're learning automation, start with Juniper. Even if you're not familiar with the Juniper, it's going to make your life so much easier in comparison. Now, what if you wanted to issue this same command, but to multiple devices here? So in this case, very, very similar to what we did before, but now I've got a list of devices that I've got statically typed out here. a few spine switches, a few leaf switches. These are just basically host names at the end of the day. Now we can do this operation with just a single script as well. I'm just gonna breeze right through. I do have an empty list right here that we're just gonna stuff data into this empty list every time we run a Python RPC against the device. And then we're gonna print out this list, which will then be full of objects or full of data out to the screen. That's effectively what we're doing. So again, just a single script, but we're actually able to execute it against multiple devices. Let me clear my terminal here and let's see if I can't pump this up just a little bit more. And 02. Now let's go ahead and type in python app.py. So this is going to take a little bit longer now that we're issuing this RPC across 6 devices instead of 1. But what's great is it's going to assemble all of that output into this previously empty object, and then we can print that out to the screen. So again, just a single script, we can actually run against multiple devices and get all of their output. And now you probably wouldn't print it to the screen. You would probably send it to maybe ServiceNow or send it to a Slack channel or send it in an email, something along those lines. You don't typically write automation just to print things out to the screen, although it's quite satisfying, I must admit. Now, this case, we asked for the data to come back as JSON. So you can see we flagged that parameter, just like what we did, again, in REST using Postman. We told it, hey, I want the data to come back to me as JSON data. And there we go. So again, super, super simple, really easy to compile and actually issue this script against multiple devices. But what if we want to take the output and we want to save it to a file, right? Again, typically you don't write automation to print things out to the screen. So what can you do to actually save this output to a remote site or a remote device? In this case, I'm just going to print the output to my local directory here called output. So I'm going to remove all objects inside of my output directory. Say yes, clear my screen. Now, if I type in tree, I can see that I've got 2 files in this directory. Oh, there's that test file that we created earlier. But I also have an output directory and there's no files in that directory, as we can see here. Now what I'm going to do is I'm going to actually issue this Python script and let's see what it's going to actually do. I think this is going to send 3 different RPCs to the devices. It's going to send a show version, get software information. It's going to send a request for all the inventory on the devices. And then it's also going to get the actual configuration and store that as JSON. It's going to write all of these to separate files within my output directory. So Python test.py, and we'll issue this. Now, as you can imagine, we're interfacing with 6 different devices. Am I in the right directory? Oh, I'm sorry, it wasn't test.py, it's app.py. That was the one that we had created earlier. Python app.py. I was wondering why that finished so quickly. As you can imagine, if we're interfacing with multiple devices, the time that it's going to take to complete is going to be greater. And the reason for that, and one of the drawbacks with Python and when you're working with Python, is that Python is what we would call both single-threaded and single CPU. And basically what that means is that when you issue your Python request, by default, Python doesn't know to interact with all 6 devices at the same time, issue commands and store all that data that came from those devices into separate files. It can't do that all at once, right? That's where other Python libraries come in. Things like async.io allows you to issue a single command against multiple devices at the same time, rather than logging into one, run a command, store the output, write it to a file, then log into the next one and kind of go down that path. That's exactly that long-winded path is how we're doing things right now, because Python is not multi-threaded, doesn't have the capability of threading these different Python tasks. Now, that's not to say that you can't do it. And that's where a lot of times automation frameworks like Ansible and Nornir, that's where they start to shine, because they handle that asynchronous communication for you so that you can greatly speed up your execution of your scripts. But now if I run that tree command again, now I can see I've got 6 different files inside of my directory of output. And if I just, oh, let's just go ahead and open up one of those files right here. Here we go. Now I can see inside of this file, there's looks to be 3 Python dictionaries, 1 for each one of those RPCs. This was the show version, this was the chassis inventory, and this was the configuration of the device. As you can see, it's going to go on and on and on and on and on. But again, the data came back in structured data format, so I didn't have to write any regular expression parsers, any of that nightmare. And now I can zero in on whatever object that I'm looking for, or range of objects that I would like to have. And for the last one, let's just look at what it is to require, or what it is to actually configure something on a remote device. Now, what's interesting on this one is that I'm importing another additional Python library into my script. In this case, it's still PyEasy, so JMPR, our stock ticker, .junos, that's their operating system. In this case, I'm also importing a method called config that comes from the utilities.config directory within PyEasy. And if you're wondering how in the world I figured that out, documentation, it's going to be your best friend. Please read the docs. And if you're a developer, please make good docs. Extremely, extremely important. But this config is going to allow me to interface with the device's configuration. You remember the device allows me to build the connection to the device, send commands to the device, but now I need to do some actual configuration options. So that's why I've imported this config library. Now I've got a new device connection. I'm literally calling it device connection, and I'm setting it equal to all the same parameters that we had talked about before. This time I'm calling Dallas Leaf 4, username and password is Juniper.123, and I'm asking for it to open up that session. Now, what we're saying is that we want to do with the config module that we've imported, or the method that we're importing here, I want to open up that device connection to the config, and I want the mode to be exclusive, which means to say that nobody else can make a configuration change while my script is executing on the device. Really important idea to consider, or at least really important to consider if you are automating things in production. You want to prevent the situation of one user is logged in, they think they're making configuration changes, and then all of a sudden your script comes in and says, it busts into the door like the Kool-Aid guy. It says, nope, I'm going to be doing all the config. So that's what the exclusive mode option is here for. It's extremely beneficial for you from an automation perspective. And then we're actually loading the commands. And if you're familiar with Juniper, this will look quite familiar for you. Here we're just saying set protocols, LLDP interface all. We can tell it that we're passing these commands in the set format, which makes sense to our Juniper friends. But if you are passing XML, or if you're passing JSON, or some other kind of clear text, you would want to be able to pass that here within your parameter. Now I'm also asking for PyEasy to give me a diff and print that out to the screen. That's what the pdiff means. It's not pdiddy, it's pdiff, meaning print out the diff. And then we commit the configuration, just like we did on the REST side of things. And then we close our connection, right? This is, you got to think this is extremely literal. Like when you're building this automation, you open a connection, will be a good person and terminate that session too. That's what the close operation is going to do here. Now, just to make sure that I'm not lying to you guys, let's go ahead and open up my browser. And here is the wrong lab. Let's go ahead and load my data center. I just want to make sure that I don't have something already running. I don't have LLDP already configured on my switch. I don't want you to think there's some smoke and mirrors going on here. Okay, so I'll click on my Podly 4 and I'll say show Lldp neighbor. I get no Lldp neighbors. I say show Lldp local information. Not a whole lot of things going on here. Don't see a bunch of list of interfaces or anything along those lines, just basic information about my device. And if I said show configuration protocols, LLDP, you might not be surprised to see that it's completely empty. Okay, so now that you believe me, let's go ahead and issue this Python script. Let's change my directory. By the way, all of these scripts are available for you. They're all open source. I have a project repository that's just basically super simple. Hey, I'm getting started with automation. How do I do it? And it's broken up into Python and Ansible right now. So if you're interested, I'll share the link with you in the chat later on how to access all these scripts and such. We'll just go ahead and type in Python app.py. And again, it's going to build that session. It's going to send the commands. Here you get the pdiff, right? So it printed out the diff to my terminal, which was awesome. I can see Ldp neighbor interface all. So just like you would expect on a Juniper device, you actually get that printed out to your console right here. Then we committed and we closed the session. And if you've worked with Juniper before, you might not be surprised to know that this is what we would call idempotent, meaning that I can run this script again and again and again, and nothing will change on the device. No commands will actually be pushed because the LLDP information has already been provisioned. That's why we're getting the none back. So in an automation world, this is worth all the money in the world, right? This concept of idempotency, meaning I can run my script 800 times a minute. Well, don't do that. But I mean, I could run it thousands of times a day and it will only push a configuration change when there's something different on the device. So extremely powerful in the automation as your scripts are going to be running either on cadence or all willy-nilly. Let's go back over to my devices now and click back on this one. Oops, no, we were here right here. So now if I just type in, hit the up arrow a couple times, show Ldp neighbors, looks like I've got a couple different neighbors right here. Yep, 3 and 4, they're connected to my data center spines. So I get that out right here. If I do the show Ldp local information, now I can see all the interfaces that Ldp is enabled on. So really, really cool. We're able to enforce some kind of configuration on our device to make sure that it was running Ldp. And we're able to run that script again over and over and over again without any fear. And the reason why I keep hearkening to that is that on networking vendor operating systems that aren't driven through the API, you're just going to have to push that config every single time. Every single time your script runs, you're going to push the full config or the config that you're trying to do, and the device is going to literally take it and it's going to accept those commands as you're issuing there. So that becomes a risk when you start looking at things like routing adjacencies, right? I don't want to always push my BGP routing config to my device and have it consider it every single time I push it, because you can affect the state of your adjacencies. I've seen some routers and switches do some really stupid things. Even when you're posting the actual same config that's running on the box, it can just goof up sometimes and cause a disaster. So this concept of a candidate configuration, a concept that's built in to the NetConf spec, allows you to safely execute your automation scripts all day and all night without any concern about what's actually taking place here. So we've got some time. I do have something else I want to talk about, but before I transition, I just want to open up the floor again. Don't be shy. If any of the NetConf stuff didn't make sense, if any of the Python stuff didn't make sense, if you'd like a little bit better explanation, now is your time to ask and my time to get some water. Okay. Sounds like everything is crystal clear, and that makes me feel extremely confident. Let's come back over to the PowerPoint deck of all things, and I just want to talk about how this actually ties into the big picture of things, right? We're not automating our networks to automate them. It's a lot of fun. Don't get me wrong. It is a ton of fun that if it clicks with you like it has with me, first of all, it took me years, but if if you start to get it and you can start to kind of visualize it and start building some basic scripts, you might be looking at some of the examples that we've done today and say, well, yeah, but like, you know, how many times am I going to change the host name on a device? Once, ever, maybe twice? Or, you know, how many times am I going to be getting Ldp neighbor information from my devices? What's the big deal? Like, what's the value prop that we get here by working with APIs? So I kind of want to just take a second to talk about this this bigger picture, and I'm going to provide a couple of different examples of when you use APIs. It's basically like, I don't know, when I was 9 years old, I'll never forget, for Christmas I got a big bucket of red Legos, and it was probably to this day still one of my all-time favorite gifts, right? Because it forces you to think in a creative fashion. Whereas today, maybe I'm getting a little bit older, but I look at the Lego toys and they're like, build the X-Wing, build, you know, the Star Trek Discovery ships. That's cool, right? But when you're given all these different tools and building blocks, you can build something completely compelling and completely unique for you. And so I wanted to just take again a second to say that automation is great, but we don't do it just for onesie twosies types of things. This is about enabling you and your networks to actually radically transform the way that you manage your environment, or how other groups inside of your organization can actually intelligently get information out of the network. Heaven forbid, your SAP server or your SAP application developers, you know they're blaming the network every single time. Now you can build tools that can actually let them know whether or not the network is a problem, and something easy that they don't have to understand SSH or how to issue commands. So you can use APIs to build integrations between all these different systems. And this use case that I've listed out right here, I'm going to be doing all my configuration changes through ServiceNow. ServiceNow is a graphical user interface. It's a SaaS web app for you know, service requests or incident management, right? But because of the integrations between APIs, ServiceNow to Ansible, that can just be over the REST API. Ansible to my network source of truth, my IPAM, my monitoring system, is asking for a list of my devices and their IP addresses and host names and such. That could be over REST API as well. Interacting with my VMware cluster, that can be over the REST API. Interacting with my Juniper network devices, that can be over REST API, or it can be over NetConf API, whatever makes the most sense. So you can start to build these entire workflows that completely transform how your team and how your network is operated. It's extremely exciting to have these types of ideas and visualizations. Here's another really good example of, maybe I want to use my messaging system that I'm already using today to communicate with my teammates and to my unhappy application SAP users. We can use tools like Slack or Teams or Discord. We can use those tools that are typically used to chat. We can use those to query the network and get information out of it and provide it back to us in a structured and easy to consume fashion. In fact, let's just go ahead and show you. It will be more compelling. So this is a Slack channel. You've probably seen one before. If not, this is just a tool for us to communicate with networking, or I'm sorry, to communicate between humans. But we can flip it on its head and actually have it actively query the networking environment. And this example, actually, I'm going to be using both REST APIs and NetConf APIs, believe it or not. So I have a tool here called HealthBot. Now, HealthBot is we have a free version of it. But what it is it's a telemetry collector, but it can also grab additional information from devices over NetConf. So we can use the NetConf RPCs to actually get live information to what's the status of my EVP and VXLAN network. And then we can render that here within a dashboard and say, you know, hot, warm, or cold, how healthy is your data center right now, or your MPLS network. Again, if you're driving this through the NetConf, 100% of the objects on your devices are available. ARP counters, DHCP releases, reservations, etc. Everything is available. So what I'm going to be doing in this workflow here is I'm going to be letting HealthBot do all the NetConf RPCs to my devices. And then I'm going to be interacting with the REST API on HealthBot. It's a single entry point where I can get any detailed information for my entire network, and I can get it and consume it in any tool that I want. In my case, I'm going to be using Slack for this. So let's just go ahead and I'm going to open up my HealthBot, which has recently been rebranded as Paragon Insights. So I'm going to type in Paragon. And what I get right here is I get a pop-up window. This is something that I built just with REST APIs. This is not something that came with the product. This was me bored last Thursday wanting to build something kind of neat. So this is by building a REST API, I can now have my Slack client say, well, what do you want to check? And I want to check the overall device health. Well, which device do you want to check on? Well, what's great is I can actually integrate this now with my IPAM. So this list of devices, you probably saw it spin its wheels just for a second. That's because it's actually reaching out to my network source of truth, my IPAM, my data center inventory management system, and it's saying, give me a list of all the devices. In this case, it's going to Netbox, and Netbox is saying, here's the devices, here's their IPs, and then we see those devices listed right here. Let me just say, give me the status of Dallas Spine 1 and go ahead and execute that call. Now, what we get back from the bot is a bot says, thank you, we've received your request. This will take about a minute, so just please stand by. But what's actually happening in the background is that the Slack app has now sent a request to my HealthBot. And it's saying, hey, HealthBot, give me all the information that you have on this data center spine or Dallas Spine 1 switch. And it's going to have all that information because it's already querying all the devices through NetConf, as you can see in the background. And then it's going to assemble all the data from the device in a easy to consume fashion and then present it right here within my chat. So I did not have to SSH to the device. I did not have to know any Junos. I did not have to know NetConf or REST to be able to consume something like this. Here we can see Dallas Spine 1 looks like it's in good health, and yep, all of the things look to be pretty good. Let's try to get something that's a little bit more unhealthy, and that's by picking on, I think Leaf 1 was my unhealthy one. Let's go ahead and do Leaf 1. Now, what I'm expecting to get back is 2 failed tests. One, my BGP underlay has failed. The overlay is still up and active. If you're familiar with data center architects, that probably sounds about right for you. Here we get the data that came back and it says, hey, your BGP is down on this device, or you've got a problem with your BGP on this device. And then you can say, yeah, you also have an issue with one of your interfaces. It's currently in a down state right now. So again, extremely easy to consume, and it can extend to any kind of environment or any other kind of test that you're running within your network. So this isn't a product sell. Again, Paragon Insights is technically, it has a free license that you can go off and play with. I'm not trying to sell the product. I'm just trying to say there's a bigger picture to be had in the realm of network automation. It's not just about making our configurations faster or more accurate or having some kind of audit trail. Automation is really going to be the enabler for us to build, us as network engineers, to build unique tools to solve problems within our environment. Every environment is unique. The architectures, the overlying principles are kind of ubiquitous, but for the most part, there's always exceptions in every environment. And you're going to run into a situation to where a vendor's tool does not fit your bill for one reason or the other. And you're going to yell, you're going to kick, and you're going to scream, just like every customer should be doing. And it's going to take a long time, maybe, to get that feature rolled in. And it might not ever get rolled in. Who knows? Why wait on the vendor? Why wait on them to produce something when you can take the time to actually build it yourself in a way that's a little bit more easier to consume? I won't say it's easy. It's not. Again, I've said it twice already on this call. It took me between 2015 and 2018 to really get decent with Python. And I'm still not great, and I probably never will be, but it takes time to build this skill. But it's a skill that's not going to go away. Again, you can see the business value of building these types of tools. You can see the operational value of how it's going to save you guys a bunch of time to manage the life cycle of your devices or just do configs. But also probably more important, like thinking of this from a selfish perspective, these are skills that will translate into any other sector of life right now. So if you want to get good at network automation, you might find that you'd rather do it in the cloud environment, or maybe you'd rather become a web application developer. All the concepts that we talked about today, except for NetConf, because it is specific for networking devices, but they're directly translatable between the different silos that you're working in. Because who knows where networking is going to be in the next 10, 15 years. To have that little layer of comfort knowing that, hey, you got a skill set that can translate into another sector, well, that might help you sleep a little bit at night. I don't know how you feel about it. But anyhow, that's it. Thank you all again for attending this this first workshop. It really means a lot to me. This is, again, it's going to be the fourth Thursday of every week for the rest of the year. I don't know if there's a formal calendar invite that's been actually formulated and sent out, but please, of course, reach out to me if you're interested in that. And let me also put in the link to my GitHub projects. So if you're interested, or I'm sorry, GitLab projects, if you're interested in some of the scripts that we use today and figuring out how you can make them work for your own environment, I'm going to go ahead and add the URL repository into the link, or into the chat right now. Oh, it looks like we've got some other chat messages here. I got it here. Okay, so there we go. Okay, so it's in the chat. Anyone, hey, again, we got some time. I'd love to give it back to you, but if you want to take the next 15 minutes to start firing off some questions to me, stump the swami, whatever it is that you want to do, feel free to take the time. I'll be here, but for everybody else that is looking to have some additional free time, thank you for joining us. This was recorded. We will be sharing it later on in a public forum. So again, thanks so much for joining out, and anyone that wants to ask some more questions, feel free to stay by. I'll be here. Thanks again.
Hey, Calvin, Corbin Murrow, I got a question that might put you on the spot a little bit with your code.
Oh. All right.
I'm a programmer. I try not to do this very much, but do you think you could show a quick example of like pulling a specific piece of information out of the XML dump? Like, I just want the host name, let's say. Sure. Yeah, see, I saw your face. I'm putting you on the spot a little bit, I know.
Yeah. No, it's fine. It's fine. I'm probably going to have something that I pull up that's actually going to help drive it rather than build it myself. The reason why this is a little bit of an eyebrow raising event is I try to avoid playing with XML too much, but it's a reality. So let me see if I can do that specific thing. Let me.
I'd take it out of JSON too. Really, just an example of like a specific. You know, specifically, I want the host name or whatever piece of information. And if you have something already built, that's great too.
No. We'll just go ahead and build it. No, let's. Oh, I don't think I'm sharing my screen. You're just looking at my face. Heaven forbid. All right, let's go ahead and try to build this out to get that. There's. Let's do this. Let's go ahead and stick with the script that we had. Actually, no, let's just go ahead and build an entirely new script here. Copy and paste here. We'll call this get config hostname. Get config hostname. and 06. Okay, so let's walk down the path of what I would do to be able to do this. So this is still going to be applicable in the NetConf world. I'm going to be asking for the device's configuration. Let me see. I'm not loading anything though. So let's see. Very first move. This will be Google. Hey Google. So we'll do Junos PyEasy retrieve config example. This will be a really common thing, and I don't know if I'll ever not first revert to documentation. So okay, this looks fairly innocuous. Let's go ahead and grab this code configuration, and I'm going to paste it here in my Visual Studio Code. We'll update the host name. It's going to be Dallas Leaf 4 is fine. Now, here's one thing that annoys me, and it annoys me with almost every vendor that I work with, is that sometimes there's like this. Sometimes developers that write documentation implicitly think that you're doing something that you're not. And in this case, what bothers me about this example is that there's like this implicit thought that you're going to be using SSH keys to authenticate with your devices. Who does that? It's extremely rare. So what this is actually missing is a user and a password field like we saw in the previous examples. So let me go ahead and just snip that from my previous code. I'll just copy this and say, is it this one? Yeah, paste right there. So I'm not authenticating with SSH keys like my private public key pair. I'm using username and password, so I'm passing that in here. Now it looks like we're going to run the RPC to say get config, and then we're going to print this out to the screen. So where we are right now, let's just go ahead and see how far we get with this. 06, clear the screen, Python, and oh, we didn't save the file. Let's save this as, oh no, we did, app.py. Okay, now I get the full configuration back. Now, as you see, it's in XML format. And so what you would have to do in order to get to narrow it down, you need to walk down the XML schema to say exactly where you want to go within your path. In XML, like I mentioned earlier, it's a, excuse me, first of all, this is bad Python. That needs to be like that. This XML's got its whole full programming language within XML, XML tools to be able to navigate this. Let me see if I can't get this coming back to me in the format of JSON instead, because that's going to be just a little bit easier for me to work with. Let's go ahead and issue that. I won't need that library, but I will need the import JSON to work with the JSON data. And we will remove this as well. And I'll just say print the object of data. So let's see if that works for us. And it didn't like that. So expected, okay. So it did not, it was actually a type error. So that tells me that there's a problem with that this probably doesn't work. Let me see. Let's validate this really quick. So Corbin, to be exactly completely transparent with you, I typically do all my automation in Ansible. So that's my knee-jerk reaction to default to.
No worries, I understand live coding comes with many errors.
Yeah, it's challenging, man. But let's go ahead and just figure out whether or not this is gonna get us exactly. Oh, look here. Looks like I just needed to pass in this options right here. So let's do that. Let's do options equals, and we'll pass in that format JSON. Oops. There we go. Options equals format.json, import the library of JSON, and then we got to remove this. That was for the XML stuff. All right, let's clear the screen and see if we're a little bit more successful with this. Hey, okay, great. So now I got my object back and it's in JSON format. So I just want to give you what I do whenever I get something like a big blob of JSON in my terminal. It's not too hard to read into it, but there's only so many like curly brackets and semicolons before your mind starts to zone out. So what I like to do in my Visual Studio Code text editor is I will paste the JSON output into a new file, and I'll change my interpreter, my highlighter, to say this is JSON data. And it's actually telling me that this is invalid. Oh, that's not JSON data. It's actually a Python dictionary. Sorry. The request package actually changes it back in between the two. So, okay, so here is my object. Let me see if I can't pretty this up just a little bit. I'm gonna use some enter keys. So this is an interesting point. This @ sign, this is, I'll just talk about it while I'm trying to make my code just a little bit clearer. I talked earlier that XML and JSON are not completely like backwards compatible. Like you can flip XML into JSON, but there's some functionality in some that don't exist in others. And so what you see right here, this @ sign, this is trying to port over XML's concept of attributes. So XML has attributes, JSON does not have attributes. And so @ sign, attribute, I guess you kind of get the gist of what it's doing here. Okay, so we kind of understand how the data structure is starting to look out here. Let me look for, what is it that you want to define? You want to find host name?
Yeah, hostname works. It's just an example of pulling a specific piece of information, like if I was hunting for something through an inventory of devices.
Sure. Yeah. No, good.
Interface IP address would work as well, or whatever kind of comes up first.
Okay. So what I'm doing here is I'm trying to just clean this up. It's just because the entire payload was on a single line. So I'm just trying to dig into this object here to figure out exactly how am I going to reach in and grab the host name. Let's see here. Okay, so bunch of this, blah, blah, blah. Ah, there we go. Okay, so there's my system. I already know, and I already know that system is going to be on the same level of groups just because I've played with Juniper quite a bit. So system groups, login, user. So here's all my usernames. I don't really care about those. We'll go ahead and exclude that for right now. And I think hostname is going to be the next thing after this dictionary closes out here, please. Okay, there we go. There's root user authentication. That's another object right here. Don't really care about that either. We're so close. There's services. So there's all my SSH config, etc. Don't really need anything in there. Let's find my gRPC, blah, 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 NetConf REST. There's the enable XP Explorer. Here it is. There's my hostname object right there. So the way that I would go about getting this data now is, let's go ahead and hit enter. Okay, so this is what we would call like our data model, or the structure of the JSON payload. And we can see that at the top level, there's an object called configuration, and then nested inside of there's something for the version for the software code. Configuration apply groups go right here. This is where our system is. Now, if you've worked with Juniper before, you're probably like, well, I already know all these words. Well, you're exactly right. The Juniper config is, again, it's XML. So it's automatically data modeled. You don't have to reverse engineer it with some crazy Yang data model. So it's already inherently data modeled. So this will probably feel extremely familiar for those that have operated in Junos. So I know I need to dig into the configuration object, then I need to dig into the system object, and then I need to grab the hostname object inside of there. So at the top level configuration, I can see that curly bracket, and because I know a little bit about Python, I know that that is going to be a dictionary or a mapping, whatever you want to call it. Traditionally, we would call it a dictionary. So I know that this is a dictionary. I look at system. System also has an open parentheses with a bunch of stuff stored in there. So I know that system is a dictionary. And I look at host name. Host name looks to just be a string. So key value pair, I need to go dictionary, I'm sorry, configuration system host name to actually derive this. So let's come back into here and say, inside of this object, I want to look into the configuration, and then I want to look into system, and then finally I want to look into host dash name. Now, there's a couple of different ways that you can navigate Python dictionaries. You can use the bracket format that I have listed here, where you list the key inside of a pair of either single or double quotes. Now, the reason why I prefer to do that is because the XML tags sometimes have invalid keys for Python, meaning, again, or invalid, key. In this case, host dash name, again, like the problem that we talked about earlier, Python, if I hadn't wrapped this in quotes, would think that I'm trying to subtract the object host with another object called name. So wrapping it in the single quotes tells Python, hey, don't be silly, go ahead and actually use this as your map to navigate down the data model. Let's go ahead and save this, and we'll see if that's actually successful. Let's roll the dice. There we go. Dallas Leaf 4. So just like that, we were able to, again, we received the full data format that came back, but we were telling Python, hey, go down here, and go down here. Now you can absolutely do that in XML as well. And I'm pretty sure the documentation is going to show how to do that. So here you would write an XML filter. In this case, they're looking at the configuration interfaces stanza, and then they're applying that filter to the RPC that they're actually committing. Now I'm interested. Let's see if we can actually do this too.
It also looks like that's actually filtering it before it sends the response, would be my guess, as opposed to pulling the full config and then parsing it. You're going to get a smaller output if you do that.
You're exactly right. Yeah, you're 10,000% correct on that. So taking the code from the example, here we're building this filter and we're setting it equal to, this is the navigation. This would be walking down, in our case, it would be walking down the XML path in order to derive that. So what I'm imagining is that the performance of this script is going to be much faster because of the point that you just brought up. We're actually filtering it on retrieval before actually doing the parsing out to the screen. So let's make sure that we saved that. This should now, let's make this work for us. So system, and then we're going to say host dash name, and we're going to spell that correctly this time, host dash name. And then we're going to close out our XML RPC like that. So this is going to hopefully also return back the value of Dallas Leaf 4. Let's go ahead and issue this. Looks like there is an issue with my, should I not have done that? There we go. There we go. Now, the data that I get back, again, it's structured in XML. That's kind of what we were expecting. Whereas in before, we were just getting the actual key value pair, actually just the value. Here, we're actually still getting the full tree to get that response. So that's pretty cool. There's also ways to filter based on additional query parameters. And I think a good way for me to show that is actually to return back to HealthBot just for a second, because I know I had to build these myself. Looking into the rules, I built a rule that looks for LSPs for ingress and egress, RSVP, LSPs. And if none of those words make sense to you, don't worry. Let's just go ahead and look into my rule. So in this rule that I built here, I'm checking for RSVP sessions for ingress and egress sessions on my PE router. Again, a lot of words, don't try to get too complicated about it. But if I look at my actual script that's actually running my sensor in this case, here I'm running the RPC of get RSVP session dash information. Again, the same RPC would be issuing on the device. That basically just is show RSVP session. I declare which fields, which in the output that I want to be aware of. In this case, the session type. I want to know whether or not it's a transport or transit or input or egress, RSVP, LSP, and a couple other fields that are also within the XML payload. Now, the reason I'm mentioning this is that in the expressions down here, you can actually do additional queries within the XPath. Actually, this isn't going to be using XPath, darn it. But again, you can get really granular and say, hey, I want to look at, here we go, right here. So here we're actually navigating the data model, and I'm saying, look for this key, right? So you can actually formulate lists of objects by saying, I want to query in on the key of interface ID, and then receive all of those objects and present them to me. So XML is super powerful. That the query language within it is, I don't know if it's completely unique. I haven't run into another data format that has that type of ability to get like super granular as far as what types of objects and how to query. Like just to be able to query within an RPC call is quite impressive. It's like having a database SQL query language for you. So again, really, really cool. Thanks for the suggestion. That was awesome.
Yeah,
got another one? Anyone else? James Downing, I see you're on the call. I'm going to call you out, James. You might not be paying attention. James, do you got any ideas, any questions? All right, James is a friend. I'll let him lead on that one. But here we are. We're over the 2-hour allocation. Again, just wanted to thank everybody for coming out. This was a lot of fun. We had a tremendous amount of success. Thank you, John Sager, for helping us getting started in the Texas Automation User Group. We're taking it, we're running it with it at a larger scale. So thanks to you, thanks to all my teammates. And please be on the lookout for next month's invite. Again, this will be the 4th Thursday of every month. So hopefully you've got enough time to hang out and learn some things. And if there's something specific that you'd like to know, if you want to know, if you want to do something on Python, if you want to do something on Ansible, or if you just want to work with APIs or REST APIs, just let me know. We'll structure the follow-up sessions based on whatever is interesting to you all. But with that, thanks again, everyone. Really appreciate your time. This was a lot of fun, and we'll see you in about a month. Have a good one.